to be, let's say, the color of, why not do yellow? We kind of want to talk about this thing here, the screen. So if we're going to talk about the screen, we do, let's say we want to deal with the screen. It has to be a capital. It's going to come from turtle, and we're going to call it yes. Nah, it's going to be too long. No, it's not. We'll keep it as yes. So if you run that, there's our yellow turtle in there, but the turtle in their shell is not visible. So now we can do things like yes to be a background color of, why not black? Then it should have something like this. So there you go. These two can be categorized as me describing my turtle, the turtle. And here we can call this me describing the screen. Now, particularly, let's add some more information to this. What can we do? Well, if later on I was to get my turtle to move forward 30, it would do that. Now, I want a bit more thickness, so let's make it, I believe it's pen size. And pen size is a strange one. You kind of want to make it a decimal, or it becomes too intense, if I can recall. So there we go, 0.8. That's correct. See, it stayed the same. Whereas if I do things like 5, that's when it gets a bit like thicker. So let's do 0.8, and let's do that one. There you go. That's kind of like the nice, looks like I actually have a pencil kind of thing. I do think it should be a little bit clearer for us though, so I'm going to go to 1.2, something like that. So that's pen size. The same goes for the size of it. Let's say shell dot shape size. I believe that one is shape size. So shape size, which for example we can convert into a circle, because I'm just like, that's more turtle-like. There we are. Shape size, this thing's a little bit big. If I made it 5, just like before, I pick the value 5, you get that. This thing is had way too much McDonald's. So as a result, we need to move this to a 0. Let's do 0.8 again, so we can see the description. That's pretty good. That's all right. Actually, nah, it's still a bit intense. Don't want this thing to be taking over my situation. So there you go. I think maybe a green would be better for the turtle, but for now, because of the video, I'm going to keep it like that. Okay, so let's get the square to then move when I want to click it, or on a keyboard, or something a bit more interesting, because otherwise you press run and it just goes on a little bit of a madness. So I'm like, we're going to define square as shell moving forward by about 60. We like 60. I think that's what was before. And what we're going to do is we're going to say, I want this to occur on click. So yes is the screen. It is going to be on click. And on click, I want it to have to be, let's say, the first button. So the first button on my mouse, and I want it to run the function square. So if I click run, and I click it, what does it say here? Type error, square, it's like, what on earth is that? Take 0 positional arguments, but 2 were given. So this means that I need, unlike a keyboard, I need to state the 2 positional arguments for my screens, the X and Y. And if I click it this time, there we are. Another thing we could do is we can technically get it to do it on key. So on key. And if you wanted to do it on key, we don't want to use button 1. That's going to confuse it. Let's just say we're going to use up. And you start with a capital. And if I run this, you'll see if I press up, nothing's happening. One, keyboard doesn't need to have such information as X and Y. Additionally, you're going to need to make sure the keyboard listens. You're going to make sure that thing listens to you. Like, next you have def square, shell forward, on key. I'm going to press up now and make sure I click this. There you go, it begins. So there's one. I'm going to do on click today because I'm not using the keys. I just want to be able to click it and have my square be produced. I don't need up. I want button 1. Button equals 1 on my mouse, and I need to recognize that the screen, when you're doing things on click and you're clicking this screen, the mouse needs to know the coordinates in terms of X and Y. So when I run this, I have this. Now I want to make a square, so let's just bang out a turn. Let's say left, and we're going to do left 90 degrees. So left shell to be left 90 degrees is the second thing that's going to occur in here. So I'm like click, and you can't really tell because it's a circle. But if I got rid of the construct of it being a circle, we'll go back to the old school. You'll see that I click it, and then its little head turned. And shape size, we make it a little bit more intense so you can see what I'm talking about. 2, let this ring run, and I click it. Yeah, so you can see it's ready. It's doing its bidding. Let's make a square for X in range. I want this to occur 0, 1, 2, 3. So 4 times. The X will produce 0, then it will produce 1, then it will produce 2, then it will produce 3. But it'll be 4 numbers, and because we haven't defined any use for that X, all that's going to do is it's going to make this run 4 times. So here we have, if I click it, 1, 2, 3, and then it's back to its original position. So this is me on click using square. Okay, perfect. So this we can label square. Now, a couple of other things we might want to do with regards to this is the use of goto. And we're going to do it, it's a little bit more complicated, but it might be advantageous later. So first of all, let's make an empty list. Let's say X list equals it's empty, and Y list equals it's empty. And we're going to fill this list up with coordinates. But in fact, what we can do, rather than making it elaborate at the beginning, let's just pick what the first situation is. So if I was to pick, for example, I wanted some large, decent square. That's a bar square. The first coordinates for my square is going to have to be this one here, 0, 0. So that's the first coordinate. No word of a lie. Now the next situation is this one here, and by the way, that's just to make that more visible. That is because this is my, let's suggest this is my x-axis. We can get it. Yeah, let's just say that's my x-axis. That's because that is my x-axis, and let's do a y-axis, something like this. And so 0, 0 is because this is the origin, the x coordinate of 0, the y coordinate of 0, the point at which they meet, the intersect of x and y, whatever you want to call it. And here is going to be, let's say that this was 60 like in our turtle. So now x has gone to 60, but y is still at 0. So something like that. And here we've got, this is going to be 60, 60, 60, 60. This here, therefore, is going to be x has moved to 0. There's no x movement, but the y has moved by 60. And I think this is the case. I'm not thinking this through elaborately because we only want a square. Now, the main point here is if I want to produce this image, if I want to get that square looking decent, I could, instead of making it do this box, I can get it to pick the coordinates, and that might be more useful later, and at least something that's worth learning. So the first coordinate is, this looks a bit too soft. The first coordinate is 0, 0. The second coordinate was, if you look back, it was 60, 0. So that means x went to 60 and y went to 0. The third coordinate was 60, 60. So that's just an interesting word, 60, 60, or words. There's the third, and then the final one is 0, 60. So x is 0, and y, my friends, is 60. Okay, now these are the coordinates. So what we want really is we want shell to just go to them, so we can write go to. And what we'd say is you want to go to the x list and the y list. and we'd be like, okay, that it's gonna do this 4 times, but all we really want is it to just go through each one of these one after the other after the other. So what we're gonna do is we're gonna say in XList, you see those square brackets in XList, I want you to go through each one per step. So X, when the first X, then the second X, then the third X, and the fourth X is going to go through these. And on here, it's like you see that Y list and the square brackets around them. I would like you to go through each position and give me the square. So see if this on click. Now you can see that the main issue is that I put 0, 0, 60, 0, 60, 0, 60, 60, and 0, 60. If you look at my picture, that makes it go here, here, and then here, and it stops there. But this is another way for you to utilize coordinates, because now there is much more power and capacity, because you can make these values out of a loop, and the turtle can move in all sorts of elaborate shapes based on mathematical coordinates or y-axis, things like that. So how do we finish this off? Let's put another one in here. We want it to go back to 0, 0. I could have used an if statement as well, but let's keep things simple for now. And then I go, and you see it's still doing the same thing. And the answer is because it's not reading a fifth value. It's reading 1, 2, 3, 4, 5. So I put this to 5. And before we let this go, let's just have a quick conversation about this, just in case there's anything that that could be missed. Let's expand this out and just take a look at this code for a second. So what happens? The main thing to recognize is that you have a value of x, and the value of x is going to go into here, and the value of x will go into here. And it's like, why would we care about that? Well, what happens is the turtle shell is going to go to a value in the X list. It's going to go to a value in that X list. And that value in the X list is going to be, at the beginning, the first one. And the reason for that is the X is going to give its first value. So the first value of X is going to give us the first value in that list. The same thing goes for y, nothing elaborate there. The first value of x is going to go into y list and take that 0. So the first position, therefore, is this one here at 0, 0. And then the next thing that will happen, is it will then go to the second value, because this will produce the second number. And same with the y will go to the second number in the y list, and that will be 60, 0. So here you'd move to 60, 0. And then finally, not in terms of the actual geometry, but in terms of me describing this, because just in case it becomes far too tedious, is that x will be the third number in the list, and y will have the same situation. It will produce the third number in the list, and therefore the turtle will go to 60, 60, and that's why it ends up here, 60, 60. And then they will move to 0, 60, because we have 0, 60 next, so 0, 60, and then it will move to 0, 0 as the fifth value in the list. So let's just see if that manifests when I click run, and I click it, and there you are, it is now doing this. And so this is how we can, I think these are the two best mechanisms to describe square or any shape, is that you can utilize the actual descriptions using geometry like left and right, and at the same time you can utilize coordinates. And I believe the coordinates is more powerful but a little bit more tedious. What you can also do, however, is you can make a function that fills out the list for you, but we will do that another time. I think we'll stop that there. Thank you.